All right, and as a sort of addendum to our discussion of rational functions, let's try to put it all together and see if we can't graph one. Now, I must preface this by saying that, in this kind of new way of instruction that we've adopted, everything being online, I don't know how closely we can really test you on this bit of information, but it's nevertheless a really good exercise. So I want to at least do one example for y'all to see. And if you want, we can discuss some more examples when we meet for class time. So to graph a rational function, the first thing we will do is write that rational function in lowest terms. So if there's any common factors to p of x and q of x, perhaps we will divide them out. I don't think we're going to see that in the examples that we're going to encounter, which is good because that's a whole extra conversation that I don't know if we want to have today. Maybe we can just have it later. So let's assume that we'll be given a rational function that is in lowest terms, so there won't be any need to divide anything out. So then the first thing we'll do is find the intercepts, right? The x-intercepts are got by setting y equal to 0 and solving. The y-intercepts are got by setting x equal to 0 and solving. Then we'll find the vertical asymptotes, which we're pretty good at now because you've done it on your quiz maybe by now. I don't know. And then we'll determine the end behavior, which is another way of saying, is there a horizontal asymptote? Is there a slant asymptote? Or maybe there's not. I think there probably will be at least one of those in the example that we'll see. Then we might determine if the graph crosses its horizontal or slant asymptote somewhere in the middle. If it does, we'll find that point and mark that out. And then by then, once we have those asymptotes sorted out, it's pretty easy to see how the function kind of how the graph of the function kind of has to look. So we'll get a couple of points from the x and y intercepts, and we'll know a lot more information than you think we'll know. We'll see it in action. We might have to evaluate the function at a couple of other places where we're not sure what the behavior is going to be, but having those asymptotes in place is going to give us a lot of mileage. So let's just start with this example. F of x equals to 2x minus 6 divided by x plus 2. I don't believe there's any common factors there. We could factor out a 2 on top and get x minus 3 is the remaining factor, but that doesn't cancel with x plus 2, so we'll just leave it how it is. So the y-intercept is always the easiest one, I feel like, to find, so we'll just go ahead and do that. Plug in x equals 0, and you get minus 6 divided by minus 2. So y equals to minus 3 is the y-intercept for this guy. Then for the x-intercepts, we will set the function equal to 0 and solve for x. So we have 2x minus 6 divided by x plus 2 equals to 0. Well, this is probably a good teaching moment. When is a fraction equal to 0? Well, a fraction is only ever equal to 0 when the numerator is equal to 0, right? We can never have the denominator be 0 because that's dividing by 0, which is breaking the sort of 0th commandment of mathematics. We can't do that, okay? So the only way you can have a fraction be 0 is to have the numerator be 0 so that this equation gets to simplify to just 2x minus 6 equals to 0. And we know how to solve that. That's like week 1 of this class. So we'll add 6 to both sides and divide both sides by 2, and we get x equals to 3 is the only x-intercept for this rational function. Okay, now to determine the vertical asymptotes, now we will set the bottom equal to 0, right? So we can factor on the top and see that nothing is going to cancel out after we factor out the top. So you can just forget that. We only need to know when is the bottom equal to 0. So x plus 2 equals to 0 when x equals to minus 2. So that is the only place that is not in the domain of this rational function, and it is the site of a vertical asymptote. Okay, so moving on, let's find the horizontal asymptote. Let's see. The degree of the top is 1 because we have 2x to the 1 minus 6. The degree of the bottom is also 1 because we have x to the 1 plus 2. So our horizontal asymptote should be the ratio of the leading coefficients. Those are 2 on the top and 1 on the bottom. So we get y equals to 2 is the horizontal asymptote. So as x goes to infinity, the y values will get closer to 2. And as x goes to minus infinity, the y values will also get closer to 2. So now let's determine, does our graph cross this horizontal asymptote? Well, namely, does the graph of the function y equals to f of x ever cross the graph y equals to 2? That would happen if we had 2x minus 6 divided by x plus 2 equals to 2. And we can try to solve this equation. What happens? We can multiply both sides by x plus 2, and we get 2x minus 6 equals to 2 times the quantity x plus 2. And now we can multiply that side out. We get 2x minus 6 equals to 2x plus 4. And the 2x's cancel, and we get minus 6 equals to 4. But that's not true. So this equation, this original one, had no solution. So we, in fact, do not have that this graph crosses its horizontal asymptote. So that's how it'll look. I know that in the end of the last video, we saw an example of a graph crossing its horizontal asymptote. This is what it'll kind of look like when that doesn't happen. We'll get some kind of non-equation at the end. Okay, so now let's put all this information together. So this is kind of sad because I've drawn the picture already, but I've drawn the vertical asymptote at -3 and the horizontal one at y equals to 2. And I've marked out my y-intercept at y equals -3 and my x-intercept at x equals to 3. And it looks like just from the asymptotic behavior that has to happen, that this is really the only way that this function can generally look in between here. It has to hug this line as x goes to -2. Sorry, I think I might have misspoke and said -3 before. So the graph has to hug the line x equals to -2 as x goes to -2 from the left. And it's on its way down there anyway, so it's just going to behave that way. And as x goes to infinity, this graph has to hug the line y equals to 2. Well, it's already underneath there because the x-intercept is x equals to 3. So it's going to have to behave this way. Now, I don't know what's going to be the behavior on the other side of that vertical asymptote, though. All the information that we found thus far is about this area of the graph. I know that as x goes to minus infinity, the graph has to hug the line y equals to 2. So I should have some behavior like that. But how do I know it's not on the other side, like down here or something? Well, this is where we just get, really high-minded, and we just go ahead and evaluate the function at some point that's on the left of the vertical asymptote. So I picked -3, and I evaluated f of -3 and got, let's see, 2 times -3 minus 6. That's minus 6 minus 6, which is minus 12. And on the bottom, we have -3 plus 2, which is -1. And minus 12 over -1 is 12, which is bigger than y equals 2, the horizontal asymptote. So we know that f of -3 is somewhere above the horizontal asymptote, so this whole piece of the graph will live above the horizontal asymptote. And so we can kind of fill in the behavior that it then needs to have over there. Okay, and so that's graphing a rational function. They pretty much all kind of work this way. You get your main kind of data points from the intercepts, and you get your main kind of structure from the asymptotes, and you fill in the way that the thing has to behave given its intercepts and its asymptotes. And if there are any other leftover regions that you don't have any information about, you simply just evaluate the function at some relevant x value in that region, and then you're able to use the asymptotes again to bootstrap and get the rest of the behavior from that portion of the graph. And so I'm not going to go ahead and do examples 11 and 12 because they're much the same. And if you want, we can discuss them when we meet in class time, or you can just look them over yourself and send me any email or something like that if you would like to know more about those. So that concludes this section, and we will meet back up next time to discuss section 3.6.